If it is vapor phase, you have to consider the partial pressure of that component. If it is exists in the liquid phase, you have to consider its mole fraction. Total pressure is nothing but it is a sum of the partial pressure of component 1 and component 2. Therefore, P total is equal to P1 plus P2. Number of moles of heptane and number of moles of octane. What's the formula of number of moles of heptane? W by M. Good morning, my dear students. I am Renuka Ashok, Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Today I am going to take the fourth session of chapter Solutions. In the previous sessions, that is in first session, second session and third session, I discussed about what are the types of solution and concentration, how concentration can be expressed by using different units. Then I discussed about solubility. Under that, I had discussed about two cases, solubility of solid in liquid and solubility of gas in liquid, as well as I discussed about Henry's law and its application. So many concepts I covered in first, second and third session. That is, in the previous session, solubility, the factor depends on solubility, solubility of solid in liquid, solubility of a gas in liquid, Henry's law, as well as its what? Application. Now, in this session, I am going to explain vapor pressure of liquid solution. You know that pressure, total pressure. Today I am going to explain vapor pressure and second law in solution chapter, Raoult's law of liquid solution, Raoult's law as a special case of Henry's law, Raoult's law as a special case of what? Henry's law. Today in this session I am going to explain about vapor pressure as well as Raoult's law, vapor pressure as well as Raoult's law. First point, vapor pressure of liquid solution, vapor pressure of what? Liquid solution. For this, I am going to take in a beaker a volatile liquid, it is a volatile liquid, let us consider volatile liquid in a beaker. It is closed by a plate. So now it is in liquid phase. It is in which phase? Liquid phase. Liquid phase. When it get converted into vapors, it is converted into vapor phase. It is converted into which phase? Vapor phase. Therefore, inside the beaker, we have two phases. So, inside the beaker, we have two phases. One is, this is liquid phase. Here it is vapor phase. It is vapor phase. Inside the beaker, we have how many phases? Two phases. The first phase is liquid phase. Second phase is what? Vapor phase. Okay. And we have to take which type of liquid? Volatile liquid. The vapor phase exerts pressure. It exerts pressure. Pressure exerted by the molecules of the vapor phase. Pressure exerted by the molecules of the vapor phase which is present above the liquid phase at equilibrium. At the equilibrium. Here, inside the beaker, there are two reactions takes place. One is forward reaction, another one is backward reaction. When liquid is converted into vapor, the forward is called as vaporization. Vaporization. Next, when we close this beaker, these vapors are converted into liquid. It is called as what? Condensation. It is called as what? Condensation. Forward reaction is vaporization. Backward reaction is what? Condensation. At any stage, the rate of vaporization is equal to rate of condensation. Rate of vaporization is equal to rate of condensation. Rate of vaporization is equal to rate of condensation. That stage is called as equilibrium. That stage is called as what? Equilibrium, or it is called as dynamic equilibrium. It is called as equilibrium, or it is called as what? Dynamic equilibrium. At equilibrium, pressure exerted by vapor phase when it is collected above the liquid phase is called as vapor pressure, as well as it is also called as equilibrium vapor pressure, Therefore, what is vapor pressure? pressure exerted by vapor phase which is present on the liquid phase at equilibrium is called as vapor pressure, and it is also called as equilibrium vapor pressure. It is also denoted by P. Therefore, to pressure exerted by vapor phase, it must be collected on the liquid phase at equilibrium. Now, this vapor pressure, when we in the container, we have two phases. This is which phase? Liquid phase, and it is which phase? Vapor phase, liquid phase as well as vapor phase. Liquid phase means you have to consider its mole fraction. Vapor phase means you have to consider its partial pressure. If it is vapor phase, you have to consider the partial pressure of that component. If it is exist in the liquid phase, you have to consider its mole fraction. Now, according to Raoult's law, now I am going to explain about Raoult's law. According to Raoult's law is applicable only for volatile liquids. Raoult's law is not applicable for non-volatile liquids. Raoult's law is applicable for volatile liquids. When volatile liquids are present, the partial pressure of each component in the solution directly proportional to the mole fraction. The partial pressure is directly proportional to the mole fraction. For example, consider a binary solution. Binary solution means which containing two liquids, two components 1 and 2. P1 and P2 be the partial vapor pressure of the two components 1 and 2. X1 and X2 are the mole fraction. P1, let us consider two components, component 1 and component 2. It has partial pressures P1 and P2, mole fraction X1 and X2. According to Raoult's law, P1 is directly proportional to X1. P2 is directly proportional to X2. According to Raoult's law, partial vapor pressure or partial pressure is directly proportional to the mole fraction. That is, P1 is directly proportional to X1, P2 is directly proportional to X2. If you remove the proportionality sign, we will put P1 naught and P2 naught. P1 naught and P2 naught are the P1 naught is the vapor pressure of pure component 1. P2 represents the vapor pressure of pure component 2. P1 naught represents the vapor pressure of pure component 1. P2 naught represents the vapor pressure of pure component 2. Therefore, component 1 and 2. Instead of 1 and 2, 1 you can take A and B also. Okay? Either you take A and B or you take P1 and what? P2. P2. Okay? So, therefore, what's the statement of Raoult's law? Raoult's law of binary solution or Raoult's law states that vapor pressure, partial pressure of each component is directly proportional to mole fraction of the solution. When you consider component 1 and 2, according to Raoult's law, P1 is directly proportional to X1, P2 is directly proportional to X2. When you remove the proportionality sign, P1 is equal to P1 naught X1 and P2 naught X2. What is P1 naught and P2 naught? P1 naught and P2 naught are the vapor pressure of pure component 1 and 2. X1 and X2 are the mole fraction of components 1 and 2, and P1 and P2 are the partial pressures of component 1 and 2. Okay. Now, when we consider Dalton's law of partial pressure, according to Dalton's law, total pressure is always equal to sum of the partial pressure of the components present in the mixture. Therefore, let us consider two components 1 and 2. Therefore, what is total pressure? Total pressure is nothing but it is a sum of the partial pressure of component 1 and component 2. Therefore, P total is equal to P1 plus P2. P total is equal to P1 plus P2. Therefore, what's the statement of Dalton's law? According to Dalton's law of partial pressure, the total pressure is the sum of the partial pressure of all components at the same temperature. Sum of the partial pressures at all component, that is P total is equal to P1 plus P2. P total is equal to P1 plus P2. Instead of P1, you write down P1 not X1. Instead of P2, you write down P2 not X2. But you know that X1 plus X2 is equal to 1. X1 plus X2 is equal to 1. Therefore, instead of X1, you write down 1 minus X2. 1 minus X2. Instead of X1, you write down 1 minus X2. So, P2 not X2. So, when you take P1 not inside, it is P1 not minus P1 not X2 plus P2 not X2. P1 not and you taking X2 as a common factor. So, P2 not minus P1 not. Therefore, how do you calculate P total? P total is calculated by using formula P1 not plus P2 not minus P1 not into X2, and you should remember the very important point, the sum of the mole fractions of components to 1 and 2, that is x1 plus x2 is always equal to 1. Therefore, x1 is equal to 1 minus x2 or x2 is equal to 1 minus x1. 1 minus x1. So, therefore, if you want to calculate the total pressure of the mixture or a solution, you should take the sum of the partial pressure of the components which is present in the solution. Okay. Now, when you consider the plots of P1 and P2 versus the mole fraction and x1 and x2 solution at constant temperature, will get linear graph. Here you take vapor pressure and along the x-axis you take mole fraction. So, when you consider x1 as constant, that is 1, you should start x2 from origin 0. So, therefore, this is become P2, and where it touches it will become P2, that is y-intercept P2 naught. Here also you keep x2 as constant is equal to 1, x1 starts from 0, will get linear graph, this value is P1, where it touches the y-axis, y-intercept is P1 naught, and this is called as P total, P1 plus what? P2. Following conclusion can be drawn from the equation. Total vapor pressure over the solution can be related to the mole fraction of any one of component. Total vapor pressure over the solution varies linearly with the mole fraction of component 2. Depending on the vapor pressure of the pure component 1 and 2, total vapor pressure over the solution decreases or increases with the increase of the mole fraction. That is, the vapor pressure increases or decreases with the increase or decreasing of the mole fraction. So, this graph which shows the P1 and P2 versus the mole fraction x1 and x2. Mole fraction x1 and x2. It is the linear graph one we can obtain by plotting, by taking vapor pressure along y-axis and mole fraction along which axis? X-axis. Now, the composition of vapor phase in equilibrium with the solution determined by the partial pressure of the component. Now, I will consider y1 and y2 are the mole fraction of the components 1 and 2 in vapor phase. x1 and x2 are the mole fractions of x1 and x2 are the mole fractions of components. Mole fractions of components 1 and 2. Mole fraction of components 1 and 2. Y1 and Y2 are the mole fractions of same component 1 and 2. But what is the difference? X1 and X2 at liquid phase. Y1 and Y2 at vapor phase. At which phase? Vapor phase. In which phase? Vapor phase. So, Y1 and Y2 are the component 1 and 2 in vapor phase. Then using Dalton's law of partial pressure, P1 is equal to Y1 P total, P2 is equal to Y2 P total. In general, Pi is equal to Yi P total. Partial pressure of each component is nothing but product of the mole fraction of that component in vapor phase into total pressure. My dear student, here x1 and x2 are the mole fraction, y1 and y2 are also the mole fraction. But what is the difference? Andre, x1 and x2 are the mole fraction in which phase? Liquid phase. Y1 and y2 are the mole fraction at in which phase? Vapor phase. Therefore, for vapor phase, what is the generalization we can give? Pi is equal to Yi into P total. P total into P. This is partial pressure of that component into this is what P total into what is Y. Y is the mole fraction of that component in which phase? Vapor phase. X is the mole fraction of that component in liquid phase. Y is the mole fraction of same component in vapor phase. On comparison of Raoult's law and Henry's law, it is observed that the total pressure of volatile component or gas is directly proportional to mole fraction. In case of Henry's law, proportionality constant is Kh and it is different from P1 naught, which is partial pressure of pure component. Raoult's law becomes a special case of Henry's law. Kh becomes P1 naught in Henry's law. So this is what? This is Raoult's law. This is a mathematical form of what? Raoult's law. This is a mathematical form of what? Henry's law. Henry's law. When you compare this, Kh is equal to P1 naught. Kh is equal to P1 naught. Therefore, by comparing Raoult's law as well as Henry's law, we can get what is Kh. Kh is Henry's constant. Kh is what? Henry's constant. Kh is equal to P1 naught. Kh is equal to P1 naught. This is how we are comparing Raoult's law as well as Henry's law. Raoult's law as well as what? Henry's law. Okay. This is about both the laws, how we can apply. Henry's law is applied when the solubility of gas in liquid. Was a statement of Henry's law? At constant temperature, solubility of a gas in liquid is directly proportional to the partial pressure of gas in liquid. Now, you have to solve problems on regarding this Raoult's law. So, please read the problem. Heptane and octane form an ideal solution. At 373 Kelvin, the vapor pressure of two liquid components are 105.2 kilopascal, 46.28 kilopascal respectively. What will be the vapor pressure of a mixture of 26 gram of heptane and 35 gram of octane? P total, they asked what is the vapor pressure of the mixture. P total is equal to, what are the two components present? Heptane and what? Octane. Again, P of heptane plus P of octane. You had to find out P total. So therefore, you had to find out P of heptane and P of octane. How can you find out P of heptane? Partial pressure of heptane. How can you calculate? It is given by what? P naught of hexane. P naught of hexane into mole fraction of hexane. Mole fraction of what? Hexane. Okay. P naught of hexane. What is vapor pressure of this P naught of hexane? 1 naught heptane. So, what is the vapor pressure of heptane? Vapor pressure of heptane is 10.52 into mole fraction of heptane. What is mole fraction of heptane? Number of moles of heptane divided by number of moles of heptane plus number of moles of octane. Therefore, if you want to find out mole fraction, you have to find out what? Number of moles of what? Heptane. Number of moles of heptane and number of moles of octane. What's the formula of number of moles of heptane? W by M. W by M. What is the weight of heptane? 26 gram and M is molecular mass of heptane. What is the molecular mass of heptane? What's the formula of heptane? C7H16 heptane. How can you got the formula of heptane and C7H16? As you know, the general formula of alkane is CnH2n plus 2. So C7, 7 2s are 14 plus 2, 16. So now it is 12 into 7 plus 1 into 6. So again 84 plus 16. 84 plus 16. How many hydrogen? 16. So therefore, it is equal to 100. It is equal to 100. Okay. Octane how many gram? 35 gram. What is the molecular mass of octane? What is the formula? C8. 8 2s are 16. H18. Therefore, it is 12 into 8 plus 1 into 18. So 8 2s are 16. 96 plus 18, that is 114. 114. Therefore, what are the number of moles of heptane and octane? If it is 26 by 0.26, it is 35 by 114.315. Therefore, you substitute here. This is 105.2 into number of moles of heptane is 0.26, number of moles of heptane is 0.26 plus number of octane is 0.315. Therefore, it is 105.2 into 0.26 plus 0.315 is equal to, this is 0.825. Now 0.26 divided by 0.825, it is 0.315. 0.315 into 105.2 is equal to 33.1. 33.1 is the answer. 33.1 is the answer for by pressure of what? Heptane. Pressure of what? Heptane. Okay. Now, pressure of octane. Pressure of octane is what? P naught of octane into mole fraction of what? Octane. P naught of octane is 46.8 into X of octane is what? N of octane divided by N of octane plus N of what? N of heptane. So, by substituting all these values, N of octane as well as N of what? Heptane, you will get 25.46. 25.46. By adding the heptane as well as partial pressure of heptane and octane, you will get the total pressure. Okay. So, therefore, by adding the pressure of octane and what? Heptane, you will get the total pressure of the mixture. Okay, you got it. So, therefore, how do you find out total pressure? Total pressure is obtained by adding the partial pressures of the individual components. Similarly, you have to do 100 gram of liquid A, molar mass 140, was dissolved in 100 gram of liquid B, molar mass 180 gram. The vapor pressure of pure liquid B was found to be 500 torr. Calculate the vapor pressure of pure liquid A and its partial vapor pressure in the solution if the total vapor pressure is what? 475 torr. So, 475 torr. Here, by using this data, that is one liquid A and liquid B is given from this data, and they are given what? Molar mass also. From this, you have to calculate what exactly. So, we have to find out what? Pure liquid. So, we will write 100 gram of liquid was the mass 100 gram. So, what is its molecular mass? 140. And B liquid 1000 gram molecular mass 180. The vapor pressure of pure liquid, that is PB naught, was found to be 500 torr. You have to calculate PA naught. Pure liquid and its partial pressure in the solution. If the PT is 475 torr. Okay. Now you have to find out number of moles of liquid A and number of moles of liquid B. How to find out number of moles? W by M. Was the A liquid mass 100? This is 140, and here 1000 gram and 180 So, 100 by 140, 0.714. Now, it is 1000 by 5.55. So, you got the number of moles. Now, I have to calculate XA and XB. What is XA and XB? XA is NA divided by NA plus NB. XB is NB divided by Na plus Nb, Na plus Nb. Na is 0.714 divided by 0.714 plus 5.55, 5.55. Here it is 5.55 divided by 0.714 plus 5.55. If you simplify that, 0.714 plus 5.55 is equal to, this is 0.128. 0.714 plus 5.55 is equal to 6.264. This is 0.714. Here 0.55 divided by 6.264. So therefore answer 0.714 divided by 6.264 is equal to 0.113 is equal to 0.113, as well as 0.55 divided by 6.264 is equal to 0.08. This is how I had taken mole fraction of A and B. Mole fraction of what? A and B. Okay. Next you have to calculate PB naught. PB naught is what? 500 torr. Okay. So PB is equal to PB naught XB. PB naught XB. What is PB naught value? PB naught value is 500. XB is 0.08. XB is 0.08. Okay. So thou will get, so this is 5.55 divided by 6.2. 0.8. 0.8. 500 into 0.8 is equal to 447 torr. 447 torr. Okay. You get PB. Next we have to get, what is that? PA is equal to, P total is equal to PA plus PB. P total, you want PA. PA is P total minus PB. P total is 475. PB is 443. You will get 32 torr. Okay. This is how do you find out the partial vapor pressure of the solution when the total vapor pressure will become 475. Therefore, if you want to find out, so P total or total pressure of the mixture, you should add the partial pressure of the components A and B. Okay. How do you find out mole fraction? Mole fraction is nothing but mass by molecular mass. Mass by molecular mass. Okay. So therefore, this session I completed, that is Raoult's law as well as what? Henry's law, and combination of Raoult's law as well as what? Henry's law. Next session, I'll come up with new concept, that is ideal solution as well as what? Non-ideal solution. Ideal solution and what? Non-ideal solution. Next, in the fifth session of the chapter, ideal solution as well as what? Non-ideal solution. So, my dear student, next session, in the fifth session, I'll come up with ideal and non-ideal solution. Thank you. Goodbye.